Welcome to my class. In continuation with Unit 2, we are doing organization of data, and in that we talked about the organization of raw data into series. We've talked about individual series, we've talked about discrete series, and today we are going to talk about the continuous series. In continuous series, there are 5 groups. We can divide them into 5 parts. The first one is what is exclusive series. Second is inclusive series. Third is open-ended series. And we have the cumulative frequency series. And we also have the fifth one, that is the mid-value series. All of these series depend upon the class, the upper limit, the lower limit. So it's quite interesting. Just have a look. We'll do one each of them one by one, and we'll start with what is known as the exclusive series. So in this exclusive series, under this method, the upper class limit is excluded, but the lower class limit of a class is included in the interval. Okay. Now for example, if we take 0 to 10. So in this and the next is 10 to 20. So suppose if they are 0.9.9, that will be included in the first, that is first class. And in the second class, it's going to be 10 to 19.9. So let's say, suppose they are marks 0 to 10. So any child who's got marks right up till 9.9 will be included in the first class, 0 to 10. And suppose if somebody's got around 19.9, suppose somebody's got 10 marks, then that will be included in the next one, 10 to 20. Anywhere about 19.9. So that will be included in 10 to 20 class. So this is what is exclusive series. Okay, and of course we'll do the construction later, but first of all let's just understand. So every class we say has the upper limit and the lower limit. So based on that we can work out the exclusive series. And now we are going to talk about the inclusive series. Now let's just have a look. I've just basically written what it is. So inclusive series is that all observation with the magnitude greater than or equal to the lower limit and less than or equal to the upper limit of the class are included in it. To say simply, both the upper limit and the lower limit are included in the same class. Suppose if you're talking about 0 to 9, 10 to 19, that means if anybody's got marks up till 9, well, it will be there in the first class. So 10 to 19, it will go to the other class. Alright, so here we see there is no overlapping of intervals. So that is, the value of the upper limit of the class never equals the value of the lower limit of the next class. So, okay, just let's talk about the difference between the two. Okay, first is in the exclusive method, if you take the upper limits and the lower limits, what happens is the upper limit of the class interval and the lower limit of the next class interval are the same. That means if it is 0 to 10, then it will be 10 to 20. The upper limit is 10, so the lower limit will be the same. Whereas in the inclusive series, what do you find? That the upper limit of the class interval and the lower limit of the next class limit are different. 0 to 9, 10 to 19. So you just see that. So you've seen that the upper limit and the lower limit of the next class are different. Now in the exclusive series, secondly, the upper limit of the class interval is counted in the next immediate class. Okay. So the upper limit of the class interval is counted. That means anybody who's getting 10 marks will be counted in the next class when you're doing the exclusive series. Now let's take this. In the exclusive series, it will be taken in the next class. But here, if you're talking about the inclusive method, both the limits of the class interval are counted in the same class. For example, 0 to 9. both are included. Say 10 to 19, both are included, both upper limit and the lower limit. Now we also can talk about, say, the suitability. It is useful in all cases, whether the value is in complete number or in fractions. That is the benefit to be using the exclusive class. But in inclusive class, it is useful only when the value is a complete number. So when we are not dealing in any fractions, then we can use this inclusive method. And in the exclusive method, there is no need to convert it into inclusive series. But in inclusive method, it is very important to convert it into exclusive series. So this is what it is. Now we come to the next one, which is known as the open-ended series. Okay, 3 of these we'll do. Now what are the open-ended series? As the name suggests, that there are 2 ends to a class, the lower limit and the upper limit. So we leave the end open. Say when we leave it open from the lower end, then what do we write? Say, so if we open the class at the lower end, then we write less than the upper limit, less than something, right? So in this, for example, if we say, if I've written 30, less than 30, 30 to 40, 40 to 50, 50 to 60, etc. Now, when we are talking about the other end, it's the upper limit. Suppose if we are talking about marks, and up till 50, everybody, normally in this class, everybody's got 50 marks. And there are only 2 students who got, say, 90, and another one has got absolute 100. So what do we do is, so in the entire class, suppose it consists of, say, around 60 students, 58 of them have got marks within this 50 marks, 10 to 50, 40 to 50. So it's an average class, but there are 2 very bright students. One has got 90 and one's got 100. So what do? We straight away write 50 and above. So that is the frequency. So that is why we leave it straight away. The upper limit, instead of putting an upper limit there and spoiling the layout of the frequencies, we just write down above, so much and above. Okay, the lower limit and above. So this is it. So this is what is known as the open-ended series. Okay, so you can get a question as what are the different types, and in the next class I'm going to do the cumulative frequency series.